2019, Unit 1, Paper 2. Nice and easy, so let's get into it. All right, question 1 from Module 1. The quadratic expression f of x is equal to ax squared plus 12x plus b, and this quadratic is divisible by x minus 3 and has a remainder of minus 27 when divided by x plus 6. Show that a and b are these constant values. So they tell us that it's divisible by x minus 3. If it's divisible by x minus 3, then f of 3 is equal to 0. So f of 3 is going to be equal to 3 squared is 9, so that is 9a, plus 3 times 12, 3 times 12, which is 36, plus b, and they're telling us that is 0. And then the next equation that they give, they tell us that when it is divided by x plus 6, remainder is negative 27. So they're telling us that f of negative 6 is negative 27. So putting in negative 6, you're going to get negative 6 squared. Negative 6 squared is 36, so you get 36a. Negative 6 times 12, that's minus 72. Plus b, that's equal to, let me see, that's equal to negative 27. So what you can do now is subtract these two equations. Just to make it simple, subtract them. 9a minus, we're going to subtract these two equations. Don't want it to be confusing, so let me use a different color. Equal to, me use black to show that we're subtracting these two equations. Subtracting them, you're going to get 9a minus 36a, that's minus 27a. Then you have 36 minus 72. 36 minus 72 is plus 108. B minus b cancel. And then 0 minus 27, so that's just 27. So you bring over 108 to the other side, and so you get negative 27a . So 27 minus 108, that's minus 81. I had to put it in my calculator. I know it is disappointing. We should all know this out of our head. And so now you divide both sides by negative 27. Dividing both sides by negative 27. And so you get a is equal to 3. So we're showing that part. So a is 3. Now that a is 3, you can substitute it into the first equation to get 9 times a. So that means that plugging it into the first equation, 9 times 3 is 27. So 27 plus 36 plus b is equal to 0. And so that means that 27 plus 36 is 63. So if you bring it over, b must be negative 63. This is an easy question. So b is negative 63. Nice and easy. So nice first question, nothing too hard. And they're giving 7 marks just to do that. Nice. Hence determine the factors. Imagine they give us a quadratic. Oh my golly. They give us a quadratic, big Cape students. So now we can just rewrite f of x now. And so f of x is equal to, it was ax squared, so it's 3x squared minus 12x plus b, and b is minus 63. I just want to check back to make sure this is what f of x will be now. 3x squared plus 12x minus 63. So it's plus 12x here. And we already know x minus 3 is a factor. So when you factorize it, you have 3x and x. This is 3. And this is minus. So this has to be 21. This has to be plus. Let's check it out. This times this is 3x squared. This times this. This times this is 3x squared. This times this is minus 9x plus 21. That's right? Yeah. So hence determine the factors. So you can tell them hence the factors of f of x are 3x plus 21 and x minus 3. Nice. Now the second part of the question, part B, it says solve the inequality. The modulus of 3x minus 4 is less than or equal to 6. Solving mod equations, then that means that 3x minus 4 is less than 6 or greater than minus 6. All right, and so all we have to do then is add 4 to both sides. Adding 4 to both sides, we get 3x is between. Adding 4, we get 10. Adding 4 over here, we get minus 2. And then we divide through by 3. When you divide through by 3, finally, you're going to get x. Why is that not? Dividing through by 3, we're getting that x is between, oh, I forgot my less than or equal to, greater than or equal to. Don't forget those signs. So x is going to be between minus 2 over 3 and x is less than 10 over 3. And if you don't believe this, check your answer. So check. How do you check? Put a number between these two. So test. Let's test x equals 5. If x is equal to 5, you get 3 times 5 is 15. 15. Wait, 5 is not between this. 10 over 3 is what? That's 3 and 1 over 3. So we have to try a number like 3. So let's fix that. I don't know why I had 10 over 3 is 10. Test with x being equal to 3. Testing with x being 3, we're going to have 3 times 3 is 9. 9 minus 4 is 5. The modulus of 5 is 5. And 5 is less than 6. So good. All right, so x is between this. All right, so you have to try any number that is between negative 2 over 3. So you can even try 0. You can try 1. You can try 2. You can try 3. You can try minus 1 over 3. But we stop at these two ends. So good. So test it and it's good. So that's the solution. All right, here. Binary operator is defined by a star b is equal to a times b over 2. Prove that star is commutative. I mean, that's trivial because multiplication is commutative. So clearly, oh boy, let's just write it down. So we have a star b is equal to ab over 2. That's a star b, ab over 2. And if you were to find b star a, you're going to see that b star a would be equal to b times a over 2. That would be b star a. b times a over 2. What b times a over 2 is the same as a times b over 2. But a times b over 2 is just a star b. So since b star a is equal to a star b, star is commutative. Nothing to that question. So since a star b is equal to b star a, then star is commutative. Nice and easy, soft, no issues. All right, now the second part says use mathematical induction to prove that 5 to the n is divisible by 1. So again, you start from case 1, where n is equal to 1. When n is equal to 1, you're going to have 5 to the 1 minus 1. 5 to the 1 minus 1 is equal to 4, and 4 is equal to 4 times 1. And so n equal 1 is true. Yes, it's divisible by 4 for 1. Say yes, n equal 1 is true. So next we go to n equal k now. So for n equal k, we're going to have 5 to the k minus 1. And since it's divisible by 4, it's equal to 4 times some number. Let's call it x. And this is where x is an integer. X has to be an integer. So make sure you tell them x is an element of z. All right, x is an integer. So some people like to go ahead and change it up and write that. So you can actually conclude that 5 to the k is equal to 4x plus 1. You can do that if you want. And then what they do is say, assume n equal k is true. That's how we do an induction. We assume n equal k is true. So assume n equal k is true. And now we need to show that n equal k plus 1 is true if n equal k is true. So for n equal to k plus 1, for n equal to k plus 1, what we're going to get is 5 to the, it's going to be 5 to the k plus 1, 5 to the k plus 1 minus 1. But 5 to the k plus 1 minus 1 is equal to 5 to the k, is equal to 5 to the k times 5. This is 5 to the k times 5 minus 1. But then what is 5 to the k? We said that 5 to the k is 4x plus 1. So let's repeat this. Replace 5 to the k with 4x plus 1. And so we have 4x plus 1 is being multiplied by 5. And then we subtract 1. And so all of this is going to simplify to work to be 20x. And then 5 times 1 is 5 minus 1 is 4. So that's 20x plus 4. And then we can factor out 4. Factoring out 4, we are going to get 5x plus 1. So it's 4 times 5x plus 1. Nice. So you get 4 times 5x plus 1. So after you get this now, 4 times 5x plus 1. So it's 4 times something called 5x plus 1, maybe a y. So it works out to be 4 times y. And so hence, you can tell them, of course, where y is equal to 5x plus 1. And so we can finally conclude, hence, n is equal to k plus 1 is true if n equal k is true. If n equal k is true. Hence, by mathematical induction, n equal k, hence by mathematical induction, the statement given is true for all natural numbers. All right, you have to conclude, you have to write your conclusion. You have to tell them that hence this statement is true. It says divisible by 4. All right, so I told him that the statement 5 to the n minus 1 is indeed divisible by 4 for all natural numbers. All right, so the statement is true. It is divisible by all natural numbers. Nice. Question 2. Question 2 says, let A be the set where x is a real number but x is greater than or equal to 1. And it says that f of x is x squared minus x. It says show that f is 1 to 1. So, of course, there are many ways you can do it. You can show it by calculation. F of A equal F of B implies A equal B. That's one such method. Or you can use the horizontal line test of the graph, which is what we're going to do. So right here, I'm going to rewrite f of x as f of x is equal to x squared minus x. We can complete the square to see that f of x is x minus 1 all squared with a half. When you half this, you get, let me see, half it. So you're going to get x minus a half square, subtract a quarter. That's f of x. All right. F of x is this, x minus a half square, subtract a quarter. All right. If you don't agree, minus b over a will give you the turning point, minus 1. Minus b divided by 2 times a, sorry. So the turning point is a half minus a quarter. And so what that means is we can sketch a curve. Just going to sketch a quadratic. This is a quadratic. And then I'm going to label the turning point first. The turning point is the point right here is a half minus a quarter nice. If that is that, you can sketch on the axis. If x is a half, 0 is somewhere here, and minus a quarter, that means x-axis is somewhere here. So these are the axes. The axis is something like this. Let me move this up a little bit. This is it. This is a perfect sketch of it. All right. So as you can see, this is when x is a half, and this is when y is minus a quarter. And it cuts the y-axis at 0 because there's no plus c. So this would be the full graph of f. But then the question said the function is only defined for when x is greater than or equal to 1. So this is when x is a half. So 1 could be somewhere right here. 1 is a root. 1 minus 1 is 0. So from right here is 1. This is 1. This has a root. X equal 1 is a root. So what that means is we don't want none of this. We're cutting off all of this. Zoop, 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 zoop. So that's what we have now. All right, so we don't even need the turning point. So this is what we have now. So we draw f of x. All right, so we draw f of x, and you can tell him this is the graph of f of x. This is the graph of f of x because it is defined for the domain where x is greater than or equal to 1. So this is x, this is y. Now what you're going to do is just put on a horizontal line Let's put a horizontal line in blue. This is our horizontal line test. And we can tell them according to the horizontal line test, it only detects one point of intersection. So yes, it is 1 to 1. We're going to tell them that now. So that's right here, horizontal line test. So we can tell them according to our horizontal line test, we can see from the graph there is only one point of intersection for all x greater than or equal to 1 with the curve. So there's only one point of intersection with the curve, with the horizontal line. Hence, f is injective. So it is 1 to 1 or injective. Nice and easy, soft. So we've shown that it's injective. Part B. Part B says f of x is equal to 3x plus 1 and g of x is equal to e to the 3x. F of x is 3x plus 1 and g of x is e to the 3x. Determine f inverse. So first thing you do is interchange x and y, and so x is equal to 3y plus 1, and then you make back y the subject, and you're going to get y is equal to x minus 1 over 3. And if y is x minus 1 over 3, this is f inverse of x. This is f inverse. So we're done. That's the first part. It says determine f inverse of g. So it means put g into f inverse. So f inverse of g of x means we're going to put g of x into f inverse. And so that will work out to be put e to the 3x into f inverse. We get e to the 3x minus 1. And this is all being divided by 3. Nice and easy, soft. Now, question C. It says solve the equation 3 minus 4 over 9 to the x minus 4 over 81 to the x. So to solve this equation, we're going to have 3 minus 4 over, I'm going to rewrite this as 9 to the x. And the next one, I'm going to put it as 4 over 9 to the x squared. That's 81 to the x, it's 9 to the x squared. Nice. You might say, why did I do that? I did that so when I multiply through by 9 to the x squared, I'm going to get 3 times 9 to the x squared minus 4 times 9 to the x minus 4 times 9 to the x minus 4. This is now equal to 0. I am now going to call 9 to the x u. Let u equal 9 to the x. No, I'm changing it. Let r equal 9 to the x. Let r be equal to 9 to the x. And so what we have is 3r squared minus 4 times r minus 4, and this is equal to 0. Nice and easy, soft. So what you do now is you factorize, and this is equal to 0. So what we're going to have is 3r times r. To get 4, it looks like 2 and 2, 2 and 2. Signs are different. The greater product is negative, so minus goes here and plus goes here. Let's check it out. Minus 6 plus 2, that's fine. So what we get is r is going to be equal to minus 2 over 3. And we're getting r is equal to 2. Now, r equal to minus 2 over 3, but what was r? Remember that r is 9 to the x. So this is now 9 to the x is equal to negative 2 over 3. Now, 9 to the x equal negative 2 over 3. That's not possible. That's crazy. That's crazy. That is crazy. You cannot raise a number to a power and get a negative answer, so that's crazy. So we can ignore that. And over this side, r equal to, then this is telling us 9 to the x is equal to 2. Since 9 to the x is equal to 2, we can take the log of both sides. And so what we're going to get, I'm not going to take the log of both sides. I see it a different way. I'm going to rewrite 9 to the x as 3 to the 2x. And so 3 to the 2x is equal to 2. Oh, but the base still won't be the same. I'm still going to have to take the log. So might as well take the log. Let's go ahead and take logs now. Just go ahead and take logs because 3 to the 2x still won't help. Let's just take logs. So taking a log of both sides, we're going to get x log 9 is equal to the log of 2. And then we divide both sides by log 9. Divide both sides by log 9. That will give us x. Dividing both sides by the log of 9. So log 9 over log 9 cancel. So x is log 2 over log 9. Since x is log 2 over log 9, we're good. So we get x equal log 2 over log 9. Log 2 divided by log 9, that's 0.135. 0.315, not 135, 315. Yeah. That takes care of this question. Wasn't much of a challenge. Nice. All right, now this question says, let the roots of the equation 2x cubed minus 5x squared plus 4x plus 6 be alpha, beta, and gamma. Write down what is alpha plus beta plus gamma. Alpha plus beta plus gamma is the sum of their roots. And the sum of their roots, again, it is given by minus b over a. So it's going to be 5 over 2. That's alpha plus beta plus gamma. Then the pairwise product, I like to call it pairwise product, meaning alpha times beta plus alpha times gamma plus beta times gamma. In other words, it's the sum of the product of two of the roots at a time. That is equal to c over a. C is 4, a is 2, 4 over 2 is 2. Then I like to call this pairwise product by 3, which is just the product of all the 3 roots, alpha, beta, gamma. That is minus d, negative 6 over 2, which is minus 3. So tell them there. So good. Next it says hence or otherwise, determine the equation of the roots whose roots are alpha squared plus alpha squared, beta squared, and gamma squared. So if an equation has those roots, then first thing we need to do is find the sum. the sum is going to be alpha square plus beta square plus gamma square. That's the sum, alpha square plus beta square plus gamma square. That's going to be the sum of the three roots. But that is equal to, they give us this formula, it's equal to alpha plus beta plus gamma all square. But alpha plus beta plus gamma is 5 over 2. So it's equal to 5 over 2 square minus 2 times the pairwise product. But the pairwise product is 2. That's 2. So what we get is 5 squared is 25. So that's 25 over 4 minus 2 times 2 is 4. Instead of saying 4, I'm going to write minus 24 over 6. 24 over, wait, 2 times 2 is 4. And I can write 4 as 16 over 4, not 24 over 4. 16 over 4. And 25 over 4 minus 16 over 4 is 9 over 4. Then now we need a product by 2. I'll call it P2. P2 now is going to be alpha squared times beta squared, which is alpha beta squared, plus alpha squared times gamma squared, which is alpha gamma all square. So now alpha gamma all square plus beta times gamma all square, which is beta gamma all square. And this is going to be equal to alpha beta all square is alpha beta plus alpha gamma plus beta gamma. And all of this, alpha beta plus alpha gamma plus beta gamma, we said that was 2. So it's going to be 2 squared minus 2 alpha beta gamma. So it's minus 2 times alpha beta gamma, but alpha beta gamma is minus 3. So it's minus 2 times minus 3 times alpha plus beta plus gamma. But alpha plus beta plus gamma is 5 over 2. So I would work this out in my head, but put that in a calculator. 2 squared minus 2 times minus 3 times 5 over 2. You get 19. This is 19. And then the product by 3 now. Is this really 19? I'm just going to check it again just to be safe. Yep, it's 19. Then the product by 3 now is equal to, product by 3 is, as you can see, the product by 3 is going to be, where we have product by 3, alpha squared times beta squared times gamma squared. That's going to be alpha beta gamma all square. And then alpha times beta times gamma again is negative 3. So negative 3 squared is 9. So now we can give them the new cubic equation. So those are just workings. So the new CE, you can write new CE, meaning the new cubic equation. New CE is given by x cubed minus the sum of the roots. So it's x cubed minus 9 over 4 times x squared plus the product by 2, which is plus 19x minus 9, and that's equal to 0. Now, if you want, you could multiply through this by 4, but I won't. I will leave it as this. This is a new cubic equation. Nice.